Before I start, I feel I should introduce myself. Hi, I'm Leah. I cannot possibly pronounce this, but at least I tried. Here's a fun fact about me. I grew up in Greece, and specifically in the island of Lesbos, which probably makes me the first geographically lesbian person you'll ever meet. If you've ever heard about me before, it's probably because of one of my open source projects. You might have used my work. Prism.js is probably the most popular and the most relevant to this talk because it's all about regular expressions. And I'm in the CSS working group, so if you have any questions about how W3C standards work, I can answer them. I've written a book. It's also translated in Russian. If you have it, I can sign it. Just come afterwards. And my day job is doing human-computer interaction research at MIT for the past 3 years. So, regular expressions have many names. Some people call them regular expression, others call them regex, others call them regex. Some even call them ASCII puke. I hope that after this talk, if you're one of those that call it ASCII puke, you might have changed your mind. That's the challenge solved today. So the first three can be summarized in one regular expression. And if you're like many developers, even though they would never admit it publicly, even just the sight of a regular expression that is non-trivial scares them. It's kind of like cats and cucumbers. Like, even though they shouldn't really scare them, they kind of do. But regular expressions are essentially pretty simple. They're just a way to describe a set of strings. For example, in JavaScript, we have regular expression literals. They kind of look like this. They start with a slash. Then you have a pattern that describes the set of strings you're trying to match. Then you have another slash. And then you have some flags, which are a combination of these 6 letters, GIM, Y, US. And some of you might be surprised that it's not just GIM. Yes, we got some new ones in the last few years. For example, the regular expression I mentioned earlier it has a caret, that means beginning of string. Then the reg is literal, just it matches reg. Then maybe 1p there. Then the pipe just means or, and the dollar just means end of string. And it's case insensitive. Don't worry about the specifics, I just wanted to go over it. But we'll go over how each of those works during the talk. Regular expressions are useful for many things. Data extraction, data validation, data transformation. They're not just useful in code, they're useful in editors, they're useful in the command line. For example, I just recently used grep to extract like a list of the most popular MIME types from my server logs. And that was just one line of code in the terminal. Similarly, I used a bunch of regular expressions to process these server logs and convert them from like 200 megabytes to only keep the 30 megabytes I actually needed. All just with Sublime and some regular expressions. If I didn't know regular expressions or if I wasn't comfortable with them, I would have to write a script for that. Who has time for that shit? So, if you have a phone or a laptop with you, you can go to regexplained.com. And I made an application for this talk. I'm going to be using it in my slides, but you can also use it to follow along and experiment as well, because you can't really learn regular expressions without practicing. So do open this and follow along, and there will be some challenges during the talk as well. And the ones that get the most correct regular expressions will win a surprise gift after the talk. So probably the is a literal. This just means, this regular expression just matches A. And the A could be anywhere in the string. And you could also have many of them because I'm using the G flag, which means global. It means get all the matches. So the first thing we learned is that regexes match anywhere unless restricted. Also, notice that here we got 2 matches. And you might be wondering, why didn't we get this as a match? And that's because matches cannot intersect. The next match starts, the earliest the next match can start is where the previous match ended. Also, they're case sensitive by default. It doesn't match this unless I turn the I flag on, and then it does. So they're case insensitive by default unless I use that I flag. Also, you can use the use syntax for Unicode characters. For example, this, just like in JavaScript strings. So this will match this heart here. Let me find it. This one. Also, you could even have emojis. So this will obviously match itself, and this will obviously match itself, but this will also match this. Because this emoji is actually a combination of characters, which you will see if I just paste it in the console. You see that it's actually 3 characters. So keep that in mind, you'll need it soon. There are a bunch of flags, don't worry about them too much, we'll go over them during the talk, but for those of you that are already experienced with regexes, you might find this summary useful. And you can also have alternatives by using the pipe character, which is basically an OR. So this matches cat, it matches bat, it also matches dog. You can also group them with parentheses, so this matches cat, this still matches cat and bat and dog. But you can also have empty alternatives, so this also matches that. Without this, it didn't. Also, keep in mind, let's say I wanted to, instead of dog, I also wanted to match do. So I'm using the trick with the empty matches here. If I do this, it does match do, but now it doesn't fully match dog. It still prefers to match do. And that's because order matters. The regex engine will match them in the order you specified. So if I do this, it will match dog and do. So yeah, order matters. And here's the first challenge, just to warm up a bit. It's supposed to be easy. It's just so that you get some experience with the system. All you have to do is match strings that contain either fizz or buzz or fizz buzz. And you have 1 minute. You just press the tweet button when you're ready. And don't worry, it won't spam your Twitter followers because it will put @regexplained before your tweets. So none of your followers will actually see it. And go. And for those of you who don't want to participate, shame on you. There is a funny cat video to watch while the others are tweeting regexes. I see we already have 1 tweet. Come on, guys, I'm sure you can do better than that. Oh, and by the way, it takes about 25 seconds to appear. So if you've already tweeted, keep in mind it will take about 25 seconds. It's not my fault, Twitter API is fucked. And the faster you tweet, the faster you can start watching the cute kitten. Okay, 4 tweets now. Excellent. It will continue going for like a few seconds afterwards, exactly because there's this delay. So let's see what we have so far. I see, some of you know about quantifiers, except that's not correct. Excellent. So, based on what we've already seen, that's why I'm not going to use the question mark, even though I know some of you already know it. Based on what we've seen, this would be a reasonable solution. However, that would match everything, regardless, even things that don't contain either fizz or buzz, because you can match with the empty string here and here, so basically even the empty string matches this, including pretty much anything else. This is correct, but a bit inelegant. This is probably a little bit better, because at least you didn't have to repeat fizz, you only had to repeat buzz. But both are correct. Okay, here's a real one. Here you have to match emojis that contain a woman. Like, here are some examples, and here are some examples that shouldn't match. And go. And you can search whatever you want. Like, obviously, I don't expect you to like remember what emojis exist and stuff. And for those of you who participated, do try to stay a little bit afterwards so that I can have a chance to look at the tweets again and decide who should win. I love this video. This is like my favorite video on the entire internet. By the way, for those of you that like CSS, how many of you like CSS? Quite a few hands. So try to think how I did this timer. This is a conic gradient that masks a video element. If you haven't heard of conic gradients, look into them. No. In the first version of this talk, it was SVG-based, and it was using dash array. But now it's just a conic gradient and a mask, and CSS animations to animate a custom property that is used in the gradient. It's on GitHub. Okay, wow, we have 13 tweets now. Time's up, let's see what we have. Very good. Very good. Many of you pretty much got there. Excellent. I kind of gave you a hint earlier. So, I hope, thankfully, nobody tried to do this, which is great, because that would be terrible. Many of you got this, which is almost there, but not every emoji that contains a woman is actually made up of multiple emojis. The family emoji is actually a singular emoji. It doesn't contain a woman. So actually, you need this. But it's okay. Those of you that got the second one are very close, and from what I saw, nobody got the third one. So, for those of you that might not be as familiar with regular expressions, it's probably no surprise that 1.5 does match 1.5. And based on what I mentioned before, you expect it to match this as well. But you probably don't expect it to match this or this. The thing is, the dot meta character matches everything except line breaks. If I put a line break here, it doesn't match, except if I use the S flag. And so if I do Control and S, you can see that now the dot matches the line break as well. Sadly, the S flag is still a proposal in stage 3. It's implemented in Chrome, but not that much more. I think it's only Chrome and Safari technical preview, but it's coming. So the S flag makes it match line breaks. And what happens if we actually just want to match the dot here? We can escape it with a backslash, and now it does match the dot, but nothing else. Here's another interesting thing. So when it was a dot, it matched everything, right? It matched the dollar, it matched the pound sign, it matched an N, whatever you wanted. Will it match a poop emoji? How many think it will match a poop emoji? Raise your hands if you think it will match a poop emoji here. Let's try it. It doesn't match the poop emoji. Why is that? That's because JavaScript is stupid and thinks that the poop emoji is really 2 characters. Now it matches. Yeah, what can you do? If you also do dot length, it also gives you 2. There are ways around it. So these are the other 11 characters that you should be escaping if you want to use them literally. And you can do that with a regular expression, of course. But soon, hopefully, we're going to get regex.escape. It's a state 0 proposal, but it does have quite a lot of interest, so I'm hopeful about it. And frankly, it's about time. So here, we have this that matches arg with like multiple A's. You need to have at least 5 A's, and then it will match a part of the string. And you can write this more succinctly like this. This is basically exactly the same. It will still match 5 A's there. But this syntax is not just syntactic sugar. It lets you do things that you can't do with just literal strings. For example, you can match anything from 5 to 10 A's. And now it matches when you have at least 5 A's, but you can keep adding A's and it still matches. And you could even say at least 5 A's, and now it matches as many strings, as many A's as you want to have. So there's syntax for at least n times, m to n times, and n times. Also, another thing to notice is that you can group them with parentheses. So here, without any parentheses, the quantifier, these are called quantifiers, it only applies to the A. If I want to match things like this, it won't work unless I use parentheses. And then it does work. Also, note that if I want to match an emoji, and let's copy it here, notice that it doesn't match because it considers it 2 characters, so I have to do the same thing. I have to use parentheses again. Now it works. Also keep in mind that it matches as many characters as it can. Even though I told it, you know what, 2 characters are okay, you can just match 2 A's. From anything from 2 A's to any more A's, as many A's as you want, but up from 2 A's. 2 A's are fine. And it will still match as many A's as it can. I can keep adding A's, and it will still match them. That's because quantifiers are, as we say, greedy. We'll see soon that you can change that, but for now, keep in mind that it will match as many as it can. Also, some quantifiers are very useful, so they have shortcuts. Here, this regex matches boo with either just a B or any number of O's, as many O's as we want, 0 to infinity. And we can write it like this, or we can write it like this, because we have a shortcut for that. It's so useful. If we want to match something that has at least 1, we can either write it like this, and you can see it matches at least, you need at least 1 O, or you can write it like this, and it's exactly the same thing. Oh, and we also have the question mark that, as you saw, some of you used earlier, which means 0 to 1. It's basically a shortcut for this. So it will match B with or without an O. Keep in mind that if your entire expression has a quantifier that goes from 0 to anything, you might end up getting very weird matches. Notice that here we got a bunch of matches. We have absolutely no O in this string, and we got 4 matches because it also matches the empty string. And you have an empty string in the beginning, between C and A, between A and T, and after T. You have 4 empty strings in there. So keep in mind, be careful of accidental 0-length matches. Here we wanted to match HTML tags and strip them, and yes, I know you should not use regular expressions to match HTML tags. But in some cases, you know what you have. You're working on an existing file that you know what kind of tags it contains. So in those cases, it can be okay. So let's say you had one of those cases, and you wanted to match HTML tags. Notice that I wrote a very reasonable regular expression here. It starts with an angle bracket. Then you have 1 or more whatevers, and then a closing angle bracket. But instead of matching the HTML tags here, it matched the whole thing. But it makes sense, given what I said before, that it will match as many characters as the regular expression allows it to match. So it started with the angle bracket here, and then it matched 1 or more whatevers until it found a closing angle bracket. It's not what you expect, but it's perfectly reasonable given how the regex engine works. So this is because quantifiers are greedy, but you can change this behavior. If you add a question mark after your quantifier, it doesn't have the same meaning as the question mark we saw earlier. Instead, it modifies how the quantifier that comes before it acts. So now, it basically made our plus quantifier lazy, and it matches as few characters as it can. So now we got the behavior we expected. and it matched both HTML tags. Notice, by the way, that if I didn't have a closing angle bracket here, it would match the first one. Like, it's not that it would fail. So here we have a regular expression that matches things like buck or duck and many other similar words. So in this case, there is a way to write this in a less unwieldy way called a character class. A character class lets you place alternative characters inside brackets, and you can see that it's much more elegant, and it still matches the same things. But character classes are way more powerful than just syntactic sugar for alternatives, because you can also have ranges. You can do A to Z in here, and now you also have Zuck that you didn't have before. But most importantly, perhaps, it's not an either-or. You can also combine the ranges with either singular characters, like now it also matches this and this, but of course not this. And you can combine them even with other ranges. So now it will also match numbers. So the brackets give you a set, a range, or a combination of both, and you can concatenate them for a union. The range is in Unicode order, for those that are wondering. And keep in mind that most meta characters don't need escaping in a character class. Now the dot just matches itself. It doesn't mean whatever character, like the pound sign, for example, still doesn't match. And it's time for another challenge. This time you have to match hex colors. And that means both hex colors with 3 characters and hex colors with 6 characters, and also lowercase and uppercase hex colors. And you shouldn't match hex colors with like 4 characters. So go. So, 17 tweets. Sweet. Let's see what we got here. 21 tweets. This will match every character, not just A to F. Same with this. It will match every letter. Same with this. Some got the A to F. Hey, hex colors can have 9 and 7 and 8. Yeah. This is better. Getting there. Oh yes, this is correct. This guy got it. And these are from before. Okay. Oh, we got 24, we got more. This one got it too. Excellent. So, this might be our first intuition, but this will also match hex colors with 4 characters and 5 characters. 4 characters are actually valid based on, according to CSS color level 4, but for this exercise, we're not considering them. And it will also match hex colors with 5 characters, which are definitely invalid. This is more correct. It matches hex codes of 3 characters 1 or 2 times, which gives you 3 or 6 characters. And it has the I flag, which means case insensitive. Did the tweets before have the I flag? Yes, this one did. Okay. If you haven't seen it, by the way, in the app, you can hover over the things and get tooltips. And it has you can press Control and I for the I flag. So, just like we have shortcuts for quantifiers, we also have useful character classes. This one is an example. It matches letters and numbers and the underscore character. And let's add a quantifier just so we see how many it matches. It will match Leah and Verou in this string. And it can also be written like this, which is much shorter, which is very useful because we need it a lot. We also have other shortcuts, like D matches digits. And we also have S. Now it matches the white space. And of course, I can add more white space. And so the problem is, the white space one is Unicode aware. It doesn't just match space and tab, it also matches all the weird white space characters. However, the W one is not Unicode aware. If I write my name in Greek, and I use W, it doesn't match. And it also doesn't match my name in Russian, or any other character set except English characters, because it's a hard-coded character class that means these letters, nothing else. We'll see soon how you can write regexes that also match Cyrillic and Greek and whatever, but /W is not it. However, it can be useful for some things, like, for example, identifiers, since they're usually in English. And you can also combine these pre-existing character classes to form more complex character classes. For example, now this will match letters, numbers, underscores, and hyphens. So for example, this whole regex will match, things that look like CSS properties. These are two snippets that both count words in a string. How many think that the first one is better? Raise your hand if you think the first one is better. Raise your hand if you think the second one is better. Raise your hand if you think they're the same and they do the same thing. Raise your hand if you haven't raised your hand in any of the 3 previous cases. Guys, why? Surely you have an opinion, right? So keep in mind that /W only matches English characters. So the first one will only work for texts in English without even accents or anything. In other cases, it will either fail to match the words, if you have Cyrillic, for example, or Greek. And if you have English words that have accents, like pâté, for example, it will actually count them as 2 words. Let's look at this. Here I have this regex, and I'm trying to match pâté, and notice that it matches twice. So based on this code, it would think that pâté is 2 words. The second one, however, doesn't have this problem, because in pretty much every language, words are separated by spaces. I'm sure there's some weird language somewhere that's an exception to this, but most languages we know, words are separated by spaces. So the second one will work much better. And here's another challenge. You have to match numbers. Numbers with either a minus before them or a plus or no sign at all. Numbers with decimals, without decimals, numbers that are followed by a decimal. And go. This video was actually recommended to me by a guy in the audience. See, I used it after all. It's a raccoon on a bicycle. "25 tweets. Nice, 28. I see as we go, more people participate. That's great. Few more seconds left. And time's up. If you tweet right now, it will still show up, but like, now probably not. So, I see many correct ones. This is pretty much there. I think this is correct, actually. Except, I don't think it needed the dot here. But yeah, it's pretty much correct. Except it will match numbers with 2 dots. Yeah, that's also a way to escape the dot. Instead of using a backslash, you can also put it inside a character class. This will match multiple dots. I see many correct ones here. And yeah, some of the last ones are. Okay. So, the first example we might think of looks like this. I saw some examples like that. And this will match the correct numbers, but it's also too relaxed. It will match numbers that are just a series of dots and don't have any digits, or have like multiple periods, or like all sorts of things like that. This will work. It has a sign optionally, and then 0 or more digits, optionally a dot, and then 1 or more digits. And this will work, except it expects the period to be before the digits always. So it will fail on numbers like 5, period. It will not match them. This is closer. It also has some false positives. It will also match a number that is just 1 period and nothing else, or a number that is plus and a period, or just a plus, or things like that. The actual correct one looks like this, but is it really worth it? In most cases, like if you're using regexes for data validation or something like that, it's probably okay to have some false positives. Like, it depends on the case, but it's usually okay. Like, this is a theme throughout this talk. Don't be too strict with your regexes. In almost every case, it's not needed. Let's suppose we wanted to match everything that is not a letter, not a number, and not an underscore. Based on what we've learned so far, we could write a character class like this, but isn't that horrible? And just to prove you that it works, see, it matches everything that is not a word character, but it's horrible. Instead, I can use the character, which means no, which negates the meaning of the character class, and then do this. And this gives me exactly the same result as I had before, believe it or not. Even though it's much more readable, it's exactly the same thing. And actually, it can get better than this. Notice that this is basically the negated form of the /w character class we saw earlier. So this also has a shortcut, like the whole thing has a shortcut, and it's an uppercase W. This is common with all the predefined character classes. Lowercase form is positive, uppercase form is negative. For example, uppercase /D means not a digit, so it will match everything that is not a digit. See, it didn't match the digit, it matched everything else. So the caret negates a character class. They're predefined versions of all the predefined, God. They're shortcuts for the negated versions of the predefined character classes. And even the dot that we mentioned earlier is a character class itself. It's actually equivalent to this. And remember that I mentioned that if you have, let's do this. Remember that I mentioned earlier that if you have a dot, it matches everything except line breaks? And you can change this by using the S flag, and now it matches the line breaks as well. Well, there are alternatives for browsers that don't support the S flag, which is pretty much every browser almost. And these alternatives are basically something like this: a positive class and the negative one together. So basically everything. This means not a space character or a space character, so everything. Same with this. See, it matches all three characters. Actually, and same with the digit. You get the idea. And in fact, there's actually something even shorter, which is this, which negates the empty set. So it means everything. So we have a lot of options. I mean, obviously, the S flag will be better when it arrives, but we're not there yet. So for now, these four options are the best we have. So before, we went over this regular expression for stripping HTML tags. Again, in cases where you know the input, you know what to expect, you don't have like weird cases, don't like bash me about saying that you can use regexes to match HTML. In most cases, you shouldn't. But so now that we've talked about negated character classes, there is also an alternative to this regex. And it's this. Start with an angle bracket, then have one or more of anything that is not a closing angle bracket, and then a closing angle bracket. And this will work just like the lazy quantifier. And another challenge, credit card numbers. So don't worry about like matching Visa or MasterCard or like the specific first digits. I just want you to match strings that contain 16 digits, not more than 16 digits, just 16 digits that can be separated by whatever, and they can be grouped in whatever way. And you have 1 minute for this. Only 2 this time? Guys, this is easier than previous ones. Okay, we got 5 now. Let's see, time's up. 6. Oh, thank you. And these are from before. It always gets some from before because it tries to match them based on the time, and it's kind of imprecise. This can just be 16. You never need to write 16,16. It's just 16. This is pretty much closer. Oh, this I think, yeah, this is the best. Let's see. So, the first one is the one that many developers do on horrible websites that we really hate. Do not do this, ever. It doesn't let people group digits at all. Like, how many times did you enter your credit card number and then you got an error message because you used spaces or hyphens? Never do this. This allows you limited grouping, but only between groups of 4, which is probably sufficient for most cases, but still, like, people might want to separate every digit by a space. Like, why restrict them? Also, because the dot matches everything, it would also match 19-digit numbers. Probably the closer one is the last one, which matches one digit, followed by anything that is not a digit, 16 times. So this will always match 16 digits. And there was a regex in the tweets that also started with /d*. That's actually better. I just liked how short this was. So remember when I mentioned earlier that you can do, when you do /w, it doesn't match Cyrillic characters. And of course, you can always do custom character classes, but who wants to do that? Well, soon we're going to get Unicode property escapes. It's an experimental feature. You have to turn on a flag in Chrome. So, sorry, you can't use it in apps just yet, but it's coming very soon. I've turned on the flag here so I can use it. And you can see that it matches my name in Cyrillic. It doesn't, however, match my name in Greek. So, see, it still only matches my name in Cyrillic. Of course, I could add Greek here, and now it matches my name in Greek, but it doesn't match it in Cyrillic. What's to do? There are also general categories, like alpha, and now it matches letters like any letter. The general syntax is Unicode property equals value. Note that it needs a U flag. Without the U flag, it doesn't do anything. For backwards compatibility, primarily. And when the Unicode property is general category, the property can be omitted, which is why I was able to just write alpha. Category equals alpha, which would be kind of horrible. It's an experimental proposal, and it's in stage 3, which means we will probably make it. It might be in ES 2018 or not, but it will make it at some point, and it's already implemented in Chrome and Safari, so its chances are very good. And of course, there is also a general category that is emoji, which is fantastic for matching emojis. And it can match all the emojis. Notice that in this case, I didn't have to use parentheses. It just works. So, this is the expression from an earlier example. The one that matches cat and bat and at and do and dog. Remember? Why does it say fizzbuzz here? I don't know. And we've mentioned that parentheses are useful for grouping. However, when you're using regular expressions in your code, like when you're just testing if a string conforms to a regular expression, what I'm about to say doesn't matter. But when you're also extracting parts of the string that match, you can extract the parts that match the parentheses separately. So they form what we call capturing groups. And capturing groups just mean that you can get them separately. If I use control and the arrow key, which you can also do in your application, you can see that it also matches, like you get a separate submatch for the C. And same for dog. You can see that it also matches the G separately. In some cases, this is very useful. For example, let's say I want to match, like, I don't know, href equals quotes something in the value in the value of that, and I want to extract the value separately without like having to do messy string operations afterwards. I can just wrap it in parentheses and extract that part. But in many cases where you're just using them for grouping and you don't need this, you can actually avoid it by using question mark and colon. And now it's not a capturing group anymore. It just does grouping and nothing else. Like if you use control and arrow key, you cannot get the separate matches anymore. And same for here. This used to be more important for performance. These days, it really doesn't matter. It's more useful when you're modifying a regular expression that is used extensively in code, and you don't want to upset references to existing groups. Let's say you want to modify it and add some grouping at the beginning, and you don't want you don't want to have to change the code that comes afterwards that gets the individual sub-matches. So you can just use question mark, colon, and it doesn't interfere with the existing code. Notice that so far all the expressions we're writing match anywhere in the string. And I kind of tried to not mention that very much in the challenges. But yeah, for example, the one that matches a credit card number, it will match numbers with like 100 digits, because it matches anywhere in the string. So you can restrict that and by using what we call anchors. The caret symbol means beginning of string, and the dollar sign means end of string. And now this matches only the string A and nothing else. So caret beginning of string, dollar end of string. Don't confuse the caret used here with the caret used inside a character class. Yes, I know it's confusing because it's the same character. Regexes in general do this a lot. They reuse the same special character to mean many different things depending on where it is. The question mark is another example. I know it's confusing, but yeah, try not to be confused by that. What can I say? You can change how the caret and dollar sign works by using the M flag. And now they don't just match the entire string, but they also match, like the caret now matches in the beginning of each line, and the dollar sign matches the end of each line. So without the M flag, this wouldn't match because it would expect the whole string to be A. With the M flag, the meaning of the caret and dollar change. So, and they mean beginning and end of lines. In text editors, when you're using regexes for find and replace, this is the default mode usually in most editors. And there's no way to change that actually, which is probably useful because in many cases you don't really want the other behavior when you're doing search and replace in an editor. Like if you want to go to the beginning or the end, you can just see it. Another challenge, dates. ISO 8601 dates. And this time you have to match the whole string because now we know how to do that. And this video is goats having a pajama party. Almost there. About 10 seconds to go. About 5 seconds. And time's up. Okay, 26. I wonder how many of these are actually dates. Okay. Is the la 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 part of the regular expression here? Okay, most are pretty much the same theme. Yeah, in many cases, In many cases, what? Okay, so many of you did a variation of this. And that will sort of work, except it will match dates like 999-99-99. So you can try to avoid, to at least have a sensible month and a sensible day. And I guess the year could be anything because there is a year 999, so that's fine. It's very far in the future, but it exists. It's a real year. But this is still not perfect. It will still allow dates like 31st of February. So it can be improved further probably, but you really don't want to go through that. If you're just doing some validation or something, this is probably sufficient for most cases. Try to be pragmatic. Before we got, in the past, where we couldn't depend on string prototype trim, this is how we used to define a polyfill for it. This is a use case for the anchors that I showed earlier, the caret and the $sign. These days, you don't really need a polyfill because it's supported everywhere. I think even i9 supports it. But this is what we used to do. And this is an example of how anchors work. Basically, this regular expression means any white space in the beginning of the string or any white space at the end of the string. And we use the G flag because if both exist, we want both, and it replaces them with an empty string. So the anchors that we showed, the caret and the $, they're what we call zero-width assertions. They don't match anything by themselves. They're sort of like conditionals of what the rest of the regular expression can match. And there are many different kinds of zero-width assertions. It's not just those two. Another example, here we wanted to match foo, but only when it's like a whole word. Not foo as part of foo bar, but only foo when it's by itself. And as you can see, here it matches regardless of where it is. So there's what we call a word boundary, which is /b, and it only matches when the foo is the whole word. And what does the whole word actually mean? So it means that it's between a /w, between a word character and a non-word character, or the beginning or end of the string. So here, it will also match the beginning of the string, or it will match when we have a space, when it's separated by spaces, but also when it's separated by any non-word character, which may or may not be desirable. For example, a hyphen is still a non-word character, so it would still match. This is how most editors work when you're doing a whole word search. Some of them are smarter, but in many cases, this is how they work. And we also have the negated version of that, a non-word boundary, which matches between two word characters or two non-word characters. So if I do this here, it will match when foo is surrounded by other characters. I have not found many use cases for this, I'll be honest. But it exists. So far, we've seen 3 zero-width assertions: the caret, which means beginning of string, the $, that means end of string, and the word boundary. Oh, 4 actually, and the useless non-word boundary. But the most useful assertions, zero-width assertions, are lookarounds. Here, this matches AB, nothing surprising here, but what if you want to match only the A, but only when it's followed by a B? But you only want to match the A, you don't want to match the whole thing. This is where zero-width assertions come in useful. This means this doesn't match anything. So the regular expression will only match the A. You can see this here. But it will only match the A if it's followed by a B. If I put a C here, it doesn't match anymore. And I can put a whole regular expression in here. I can have alternatives. Now it matches if it's followed by a C. And I can even do things I can even use quantifiers. This means it needs to be followed by a B somewhere, but it doesn't have to be immediately after. It could have any number of characters after. I could even do this. It needs to be followed by a word character somewhere. And this means it could have like any number of characters. As long as there's a word character somewhere, it will match. And I can even combine them because they don't advance the position of the match at all. I can have multiple. So here, this means it needs to be followed by a word character or a dollar sign somewhere. So if I only have like pound signs or percent signs or whatever, it won't match. If I have a word character, it will match. Oh, sorry, this needs to be escaped. If I have a word character, it still won't match. It also needs a dollar, and then it matches. And we also have the negative version of this, which means it should not be followed by a dollar sign. So now if I delete the dollar sign, it matches. And this is also useful in what I call look-ahead hacks. I wrote a blog post about them like many years ago. It was about how you can use look-ahead hacks to basically do set operations in regular expressions. For example, intersection. You want to verify that a password is at least 6 characters and has a digit and has a letter and has a symbol. And this is how it's usually done. You have like multiple checks. And this is a legit choice. It's readable. It's very human readable. It's good. It's better code than what I'm about to show you. But it's also possible to do it like this. And in some cases, it might be worth it. Like it might be useful to do it with regular expressions because you can also, for example, you can put them in the HTML5 pattern attribute. So you can like validate a password right there just by using HTML5 validation without having to write any code. And what does this mean? This matches the beginning of the string, this matches the end of the string, this matches 6 characters, and this means it must contain a digit somewhere. Notice the $, like the digit needs to come somewhere, not immediately after. This means a letter, and this means a non-word character or an underscore. We can also use negative look-aheads for subtraction, like something that matches this regex, but not this regex. For example, if we want to match an integer that's not divisible by 50, it's relatively easy to match to match numbers that are divisible by 50, but it's way, way harder without this hack to match regexes that are not divisible by 50. So what do? This matches any integer, and then we use a negative look-ahead, which matches numbers that are divisible by 50. So by excluding these, the whole regex matches numbers that are not divisible by 50. And it's a variation of this where basically what's negation? It's subtraction where the first group is everything. So this will match any string that doesn't contain foo. And you might be wondering, okay, so we've seen how to match strings that strings that have like an A that is followed by a B. But how do I match a B that follows an A? Like what's like the opposite of look ahead? And you can match it with this syntax. Notice that here I'm matching a B that is followed by an A. And you might be wondering, especially if you know about regular expressions in JavaScript before this talk, you might be wondering, what are you doing, Leah? We don't have look behind in JavaScript. How many thought of that? A few. So we didn't have look behind in JavaScript. And we sort of don't really have look behind in JavaScript now because it's not supported everywhere, but it's coming and it has implementations. And we also have the negative version of this, which is a B that doesn't come after an A. So this will match, this will not. It's basically, the syntax is like the look ahead, except it also has an angle bracket. And it's an experimental feature. It's a proposal in stage 3, only supported in V8 behind the flag, which is what I'm doing right now. I'm using Chrome with a flag. But I'm so excited about this. It will make, when we can depend on it, it will make so many use cases easier, especially syntax highlighters. Like, so many of Prism's expressions will be simplified so much. And this regular expression tries to match strings like that are quoted, either with double or single quotes. So it will match this, it will match this, but it will also match things like this. And notice that it doesn't match them the way we expect. We expect if we start with a single quote, the double quotes inside the string shouldn't really matter, right? Except that's not what we told the regular expression. We told it something that starts with either a single quote or a double quote, and something that ends with a single or a double quote. So that's what it does. It does exactly what we told it. In practice, what we don't want anything here. We don't want any kind of quote. We want the kind of quote we started with. When we start with a single quote, we want to match a single quote here. When we start with a double quote, we want to match a double quote there. How can we do that? We can use what's called a back reference. Remember when I mentioned that parentheses create capturing groups and that you can use those submatches in your code? You can also use them in your regular expression as well. If you do /1, it matches whatever this capturing group matched. So in this case, it will be the single quote. If it started with a double quote, of course it matches the double quote. These are called back references because they match a previous capturing group by index. Like if you had another group, it would also match, like you could use /2, /3, and so on. And you might be wondering at this point, but what about escaping? Like in real strings, I can use backslashes. So what about that? Even though I've escaped this quote, it still matches it. So let's see, how would we solve this? One solution would be to do something like that. And now this works, but what happens if we have an escaped backslash? If I have a backslash here, and then like something else, and then a quote, that shouldn't work. This is escaped. The backslash is escaped. So what we can do instead is this beauty. This is not my regex. This is by Stephen Leviathan. We had a correspondence when I made the first version of this talk, and he came up with it. This is beautiful. It takes advantage of how the regular expression engine does the matches. And basically, when it finds a backslash, it will match the thing that comes after the backslash, just because this is greedy. So if it can match one, it will match one, and then it has to match whatever comes out of it. So you can see how this works. It's beautiful. And this is the last challenge today. I know you might be tired. For this one, you have to match the language of correctly nested parentheses. So parentheses that have the same number of opening and closing parentheses. You can see some examples that you should match and some examples that you shouldn't match. I know. But the timer. Anyway, I'm almost done, don't worry. I know I'm running over. So a few seconds left. And time's up. Let's see, very few tweets this time. Whoa. Haha, I see some of you are onto me. Nice try. Hee. Not just Perl. So, I trolled you here. That language is not a regular language. You cannot do everything with regular expressions. Some languages, programming languages are an example of that. Some languages cannot be matched by regular expressions, and they need what is called a context-free grammar. The language of correctly nested parentheses is very simple to do with a context-free grammar. It only takes these 3 lines. But it's impossible with a regular expression, at least with regular expressions as they are defined traditionally. There are some languages that extend what regular expressions can do. I think even back references kind of extend what regular expressions can do according to classic CS theory. But JavaScript is not one of these languages. In JavaScript, you cannot describe that language, the language of correctly nested parentheses, with regular expressions. In some other languages, you can. I think .NET languages are an example. There are a few where you could match this with their flavor of regexes. Not in JavaScript, though. So before I leave you, some best practices. As I mentioned in this talk, practicality is usually more important than precision. Don't try to match an expression too much. Like, this is an example of a regular expression that correctly matches an email, or at least used to correctly match an email. I don't even know if it works anymore. You should never use things like this. If you want to just validate an email, like, some people do things like that. This will fail with international characters, with long TLDs, with all sorts of things. Just do something relaxed, like beginning of string, non-white space character, an @ sign, some more non-white space characters, a dot, and some more non-white space characters. And there should be a $sign here that I forgot. Like, you want to help the user when you're doing validation. You don't want to match every single case. I mean, they can always give you an email that is fake, and you can't send to it, even if it looks correct. Like, you can't guard against every possible case when you're doing form validation. You're just trying to help the user. Don't get in their way. It's really annoying when you enter your email in a form and it complains that it's not valid. So, like I said, it depends on your use case whether you prefer to accept false positives or false negatives. Usually, it's more okay to accept false positives than false negatives. You don't, for example, in form validation, you never want to have false negatives. False negatives would be if a user enters correct input and you tell them that it's wrong. You never want to do that. False positives are much better. In some other use cases, false negatives might be less important and false positives might be much worse. It depends on what you're doing. In most cases, you will have to pick one of the two. It's often hard to write a very, very precise regular expression, and even when it's possible, it's often not a good idea. So keep it simple. Sometimes not using regular expressions is a better choice. If you just want to compare if a string is equal to another string, you don't have to use regular expressions. Just compare the two strings. Similarly, if you want to check just if a string starts with another static string, contains another static string, just use index of. Or if it starts with another string, just use index of and compare it with 0. Like, you don't always need to use regular expressions. For performance, try to avoid greedy quantifiers. Always use the question mark after them unless you have a reason not to. If you can use anchors, like beginning of string, end of string, use them. It's much faster. In general, be as specific as your use case allows. Remember what we just said. Prefer non-capturing groups. This is becoming less important now, but still non-capturing groups are faster typically because the browser doesn't have to, the engine doesn't have to remember what it matched. And minimize backtracking. The last one might need some more explanation. It has to do with how the regex engine matches. So it will try to consume as many characters as it can, and then when it realizes it made a mistake, it will backtrack one character, then it will try again, then another character. You can see the number of possible combinations can be huge, and especially when you have nested quantifiers, it can be way worse. This regular expression is an example of what we call catastrophic backtracking. I know there are better ways to write this, a regular expression that does the same thing. But bear with me for a moment. Exactly because this has infinite quantifiers that go between like 1 and infinite times, and they are nested, the number of possible combinations is huge. It doesn't really matter when we have a short string like this, but when we start adding x's, notice this indicator here. When we add x's, now we go to slower matching, and it's even slower. And notice how it grows. At this point, it's taking a while. This is 1 second now. Now it's 2 seconds. And now it's, I'm not going to add another x, 4 seconds. If I add another x, I think it goes to like 10 seconds. So you can see that it's not just a theoretical concern. It's not just something that happens in like very tight loops or huge strings or things like this. This is real. Of course, it only happens when it doesn't match. If there is a match, it's very fast again. See, when there is a y at the end, super fast again. So this is called catastrophic backtracking, when backtracking causes the engine to become extremely slow. It only applies when there's no match, and a way to avoid it is to avoid nested quantifiers. For example, this one could just be written as this. And then it's fast, whether you have a y at the end or not. It goes to green again. So that's all I had. These are the video credits. If you like any of these videos, you can click on them from the slides that I have online. Thank you so much.